Nenomatica, where mathematics meets YouTube excellence. In this lesson, we build a strong visual intuition for completing the square. We start with a concrete example and then generalize it to a formula you can use every time. Example: what constant must we add to x squared plus 6x to create a perfect square? The goal is to recognize the missing little square in the diagram and tie it to the algebra. Draw the picture of x squared plus 6x. Imagine a large square of side x. Now attach two rectangles, each with one side x and the other side 3. Together they represent 6x. Notice the shape almost becomes a larger square of side x plus 3, but it is missing a small 3 by 3 square in the corner. That missing piece has area 9, so add 9 to complete the square. Key idea: x squared plus 6x becomes a perfect square when you add 9. That 9 is 3 squared, where 3 is half of 6. Now, let us generalize. General case: take x squared plus ax. General case: take x squared plus ax. Split the linear part evenly. That's a over 2 attached in both directions. You now miss a little square whose side is over 2, so its area is a squared over 4. Therefore, add a squared over 4 to complete the square. In this lesson, we will complete the square for 3 expressions, exactly following the same two-step algorithm. Compute b over 2 squared, then add that value and rewrite as a perfect square. The rule when the leading coefficient is 1 is add open parenthesis b over 2 close parenthesis squared. First expression: x squared minus 16x. Step 1, compute b over 2 squared. Negative 16 over 2 quantity squared equals negative 8 squared equals 64. Step 2, add that number and factor the perfect square. X squared minus 16x plus 64 equals the quantity x minus 8 squared. Second expression: y squared plus 7y. Step 1, compute b over 2 squared. 7 over 2 quantity squared equals 49 over 4. Step 2, add that amount and write the perfect square. Y squared plus 7y plus 49 over 4 equals the quantity y plus 7 halves squared. Third expression: x squared plus 8x. Step 1, compute b over 2 squared. 8 over 2 quantity squared equals 4 squared equals 16. Step 2, add that value and rewrite as a square. X squared plus 8x plus 16 equals the quantity x plus 4 squared. Recap: each time we square b over 2, add that number, and then factor the perfect square trinomial into a binomial square. Great work following the exact algorithm. When the leading coefficient is 1, completing the square is fast and reliable. In this lesson, we will derive the quadratic formula by completing the square, and then use it to solve a concrete example. Step 1. Start with the general quadratic equation. ax squared plus bx plus c equals 0. Here, a is not equal to 0. Step 2. Divide every term by a to make the x squared coefficient equal to 1. Step 3. Move the constant term to the right side. Step 4. Take half of the x coefficient, which is b over a. Half of that is b over 2a. Now square it to get b squared over 4 squared. We will add this same quantity to both sides. Step 5. Add b over 2 squared to both sides. The left side becomes a perfect square trinomial. Step 6. Factor the left side as the square of a binomial, parenthesis x plus b over 2 a parenthesis squared. Step 7. Combine the right side over a common denominator, 4a squared. That gives b squared minus 4ac, all over 4 squared. Step 8. Take the square root of both sides. Remember the plus or minus. Step 9. Subtract b over 2a from both sides to isolate x. This is the quadratic formula. In this example, we'll complete the square for the quadratic expression x squared plus 6x plus 7. We'll follow the exact textbook algorithm. Add and subtract half the x coefficient squared, then factor and simplify. Step 1. Place 2 blanks so that we can add and subtract the same quantity without changing the value. These go after the x squared plus 6x and after the plus 7. Next, the algorithm says add the square of half of the x coefficient and subtract the same amount. Here, half of 6 is 3, so the quantity is parenthesis 6 over 2 end parenthesis squared. Now, write the expression with the added and subtracted quantity. x squared plus 6x plus parenthesis 6 over 2 end parenthesis squared plus 7 minus parenthesis 6 over 2 end parenthesis squared. Group the first three terms into a perfect square trinomial and factor it. That gives parenthesis x plus 6 over 2 end parenthesis squared plus 7 minus parenthesis 6 over 2 end parenthesis squared. Evaluate the simple numbers. 6 divided by 2 is 3, and 3 squared is 9. So we get parenthesis x plus 3 end parenthesis squared plus 7 minus 9. Finally, combine the constants 7 minus 9 to get negative 2. The completed square form is parenthesis x plus 3 end parenthesis squared minus 2. In this lesson, we will complete the square for the expression 2z squared minus 12z, following a clear 5-step algorithm. Here is the example we will transform step by step. Step 1. Factor out the greatest common factor. 2 multiplies both terms, so we factor 2 out to get 2 times the quantity z squared minus 6z. Step 2. Prepare to complete the square. Inside the parentheses, the coefficient of z is negative 6. We take b over 2 squared. The magnitude is 6 over 2 squared, which equals 3 squared, which equals 9. Step 3. Add and subtract the square inside the parentheses, which adds 0 in a helpful form. That gives 2 times the quantity z squared minus 6z plus 9 minus 9. Step 4. Group the perfect square trinomial and the constant. We rewrite as 2 times the bracket open z squared minus 6z plus 9 bracket close minus 9. Step 5. Recognize the perfect square trinomial. Z squared minus 6z plus 9 equals the quantity z minus 3 squared. The final completed square form is 2 times the quantity z minus 3 squared minus 9. We will follow a clean 4-step algorithm that mirrors the textbook method exactly. Step 1. Copy the expression and identify the number to complete the square. Take half of the x coefficient, which is 4 divided by 2, then square it. That gives 4. We will use this 4 in the next line. Step 2. Add and subtract that same 4 inside the expression so that the value is unchanged. This line must read exactly as x squared plus 4x minus 1 plus 4 minus 4. Step 3. Group the first 3 terms as a perfect square trinomial and combine the constants. We write left parenthesis x squared plus 4x plus 4, right parenthesis minus 5. Step 4. Recognize the perfect square. X squared plus 4x plus 4 equals parenthesis x plus 2 squared. Therefore, the completed square form is parenthesis x plus 2 squared minus 5. In this video, we will solve a quadratic equation by completing the square. Our example is 2x squared plus 3x plus 1 equals 0. Step 1. Factor out the leading coefficient of x squared from the trinomial. We write 2 times the quantity x squared plus 3, halves x plus 1/2 equals 0. Since 2 is not 0, the inner factor must equal 0. Step 2. Move the constant term to the right side. Step 3. Take half of the linear coefficient and square it. Half of 3 halves is 3/4. Squaring gives 9/16. Step 4. Add 9/16 to both sides. The left side becomes a perfect square trinomial. Now simplify the right side. Negative 1/2 is negative 8/16, so we have negative 8 plus 9 over 16, which equals 1/16. Take square roots of both sides, remembering the plus or minus. Finally, solve both linear equations. When the right side is plus 1/4, x equals negative 1/2. When the right side is minus 1/4, x equals negative 1. So by completing the square, the solutions are x equals negative 1/2 and x equals negative 1. In this lesson, we will solve a quadratic by completing the square. Here is the example we will solve x squared minus 6x plus 1 equals 0. Step 1. Isolate the x terms. Move the plus 1 to the right side by subtraction. Step 2. Compute the square. You must add to complete the square. take -6 divided by 2 and square it. That is -3 squared, which equals 9. Step 3. Add that value to both sides to keep the equation balanced. Step 4. The left side is now a perfect square trinomial. Write it as the square of a binomial. Step 5. Use the square root property. Take the square root of both sides, and remember the plus or minus. Step 6. Solve for x by adding 3 to both sides. For an intuitive picture, in this example, we will solve the quadratic equation by completing the square. Our equation is x squared plus 6x minus 187 equals 0. Step 1. Move the constant to the right side. That gives x squared plus 6x equals 187. To complete the square, look at the coefficient of x, which is 6. Half of 6 is 3, and 3 squared is 9. So we add 9 to complete the square. Here is a diagram. The large blue square is x squared. The two orange rectangles together represent 6x, and the missing green corner is 9, which completes a big square of side x plus 3. Step 2. Add 9 to both sides. X squared plus 6x plus 9 equals 187 plus 9. On the diagram, that is exactly the small green square being added. Step 3. The left side is now a perfect square. We can write it as left parenthesis x plus 3 right parenthesis squared equals 196. Step 4. Take the square root of both sides. That gives x plus 3 equals plus or minus 14. Step 5. Solve the two simple linear equations. X plus 3 equals 14 gives x equals 11. X plus 3 equals negative 14 gives x equals negative 17. Therefore, the solutions are x equals 11 or x equals negative 17. In this lesson, we will solve a quadratic by completing the square. We will follow the steps exactly, line by line, and keep the structure identical to the worked solution. Here is the example. Step 1. Factor out the coefficient of x squared. That gives 3 times the quantity x squared minus 1/3 x minus 2/3 equals 0. Step 2. Because 3 is not 0, we can divide both sides by 3. So the equation reduces to x squared minus 1/3 x minus 2/3 equals 0. Step 3. Move the constant term to the right side. Now we have x squared minus 1/3 x equals 2/3. Step 4. To complete the square, take half of the coefficient of x and then square it. Half of negative 1/3 is negative 1/6. Squaring negative 1/6 gives 1 over 36. Step 5. Add this square to both sides to complete the square. X squared minus 1/3 x plus 1 over 36 equals 2/3 plus 1 over 36. Step 6. The left side is now a perfect square. It becomes the quantity x minus 1/6 squared. On the right side, 2/3 plus 1 over 36 equals 25 over 36. So we have the quantity x minus 1/6 squared equals 25 over 36. Step 7. Take the square root of both sides. X minus 1/6 equals plus or minus the square root of 25 over 36. That simplifies to plus or minus 5 over 6. Step 8. Solve for x by adding 1/6 to both sides. X equals 1/6 plus or minus 5/6. We now compute the two values. In this lesson, we will solve a quadratic by completing the square, following the exact step order shown in the provided solution. Example: solve the quadratic x squared minus 3x minus 4 equals 0. We will reproduce each written step faithfully and explain the idea along the way. Step 1. Multiply the left side by 1, which does not change the equation. 1 times the quadratic equals 0. Step 2. Note that 1 is not equal to 0, therefore the original quadratic still equals 0. Step 3. We keep the same equation and move the constant term to the right. Then we obtain x squared minus 3x equals 4. Step 4. To complete the square, take half of negative 3 and square it. Half of negative 3 is negative 3 halves, and squaring gives 9/4. Step 5. Add 9/4 to both sides. Then factor the perfect square on the left. Factor the perfect square on the left. Step 6. Take the square root of both sides. x minus 3 halves equals plus or minus the square root of 25 over 4, which simplifies to plus or minus 5 halves. Step 7. Solve for x by adding 3 halves to both sides. X equals 3 halves plus or minus 5 halves. Finally, compute both branches explicitly, exactly as written in the solution. For the plus case, 3 halves plus 5 halves equals 8 halves equals 4. For the minus case, 3 halves minus 5 halves equals negative 2 halves equals negative 1. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenomatica, where mathematics meets YouTube excellence.